The gradient of a line is a measure of the slope of a line or the steepness of a line, and whether the line is sloping upwards to the right or downwards to the right. And traditionally the way we start off thinking about a gradient is that the gradient is equal to the rise over the run. So however much a line is rising over how much it runs along. And if we look on our diagram here again, we've got the points A and B, and the rise is a measure of this vertical side of a right-angled triangle, and the run is the measure of this horizontal side of our right-angled triangle. So here we have the rise, and here we have the run. Now you might be able to see that in order to determine the rise, then what we really need to do is to subtract the y value for b from one y value for b from another y value for b. So we'll go back to our formula. Now the letter that represents gradient is a lowercase m. Not like the midpoint where it's uppercase M, we use a lowercase m. So the rise is determined by subtracting one y value from the other, and typically we'll have y2 minus y1. And to determine the run, we're going to have to subtract one x value from another. So we look for the x values. Here's the x value for B, and then we have the x value for A, and we subtract one from the other. So again, typically, formulas in textbooks will write this as x2 minus x1. And that would be our formula for finding the gradient or the slope of a line. Now the truth is, it doesn't really matter which of those values comes first or second. You can try this for yourself, but if I rewrote that formula as y1 minus y2 over x1 minus x2, you will end up getting exactly the same value for the gradient of a line. The important thing is that if you start with the second y value in the numerator, then you've got to start with the second x value in the denominator. If you start with the first y value in the numerator, then you've got to start with the first x value in the denominator. But either way, both of these are going to give you the same value for the gradient.